Hello guys and welcome to this tutorial. I'm going to make a very short introduction to CameLigo, which is syntax used by the Ligo language to write smart contracts on Tezos. So we're going to write from scratch the contract that you get when you load the Ligo web IDE the first time. So that one, when you click on Increment CameLigo, you get this template. And so we're going to write it from scratch and introduce some concepts of the CameLigo language. So let's start right now. I'm just going to delete everything. And when I write a contract in Ligo, I like to think of the contract like a Milkerson contract. So there are like three main parts of the contract. The first part is the parameter of the contract. So by the way, that's how you write comments in CameLigo. The second part is the storage of the contract. And the third part, of course, is the code of the contract. Let's start with the parameter. So in the example of the increment contract, we have actually two entry points of the contract. So in order to represent this kind of value, this kind of setting in CameLigo, we're going to use a variant. So that's how it works. So we're going to define the type of the variant. So we write type and we give a name to that type. So here it's called action, and then equal. And now we're going to define the variant. So first we start with the vertical bar like that. And so the first entry point of the contract is named increment. So that's how you write it with the capitalized I at the beginning. And now we're going to tell Ligo what kind of data type we expect when the increment entry point is called. So to do so, we type of, and now we can put the type that we expect, which is going to be an int. When this one is done, we can continue with the second entry point, which is decrement. So following the same syntax of, and we're also going to expect an int. So here this variant here indicates to Ligo that our contract is going to have two entry points, increment entry point, decrement entry point, and the increment entry point is going to expect a value of type int, and the decrement entry point is also going to expect a value of type int. When we're done with that, we're going to continue with the storage. So here the storage is quite simple, but still better to give it an alias, so it's easier to remember in your code, you know what's happening, and it makes it a little bit clearer. So same thing here. We start with type. We're going to call it storage, and storage is just an int. After we've done that, we can continue by writing the code of the contract, the logic of the contract. So every Ligo contract has a main function that's going to be in charge of dispatching the different calls to different entry points and calculating the new storage. So that's how you write a function in CameLigo. You start with the let keyword and then you give it a name. So in general, this function is called main, but actually you can call it whatever you want. And here we're going to use a tuple that's going to contain the parameter and the storage. So this part here can be a little bit confusing if you're coming from JavaScript, because we're going to use parents like that, but actually that's the syntax for the tuple in the context of this function. And on the left side, we're going to have the parameter that's called in the contract. So we're going to call it P. And on the right field, we're going to have the storage. which we're going to call S. And now we're going to type those two variables. So this one, the parameter, is going to be of type action that we defined just above, a little star, and the type of the storage, which is storage. And we also, so it's not in the template, but we would like also to type the return value of the function, and the main function of the contract is always going to return a list of operation and the new storage. And once we're done with that, equal sign, and then we can start writing the body of the function. So here the goal of the function is going to calculate the new storage according to the values that are passed to the entry points. So let storage, so that's going to be the new storage that we're going to get, equal, and here we're going to use pattern matching. So to use pattern matching, we start with the match keyword, and then we're going to pass the variable that we would like to check. So here's going to be the parameter of the function. I mean this one here, and we continue with width, and we use a vertical bar again. And now we're going basically to, for the cases of the pattern matching, to use the names of the entry points here. So the first one is increment, and remember that increment is going to expect a value of type int. So we're going to store it in a variable, so you can also give it whatever name you like, which is going to call it n. After that you put an arrow, and on the right side of the arrow, that's the part where you're going to calculate the new storage. So in the case of increment, we want to add the value that's passed to the increment entry point to the current storage. So that's the value that's going to be passed to the contract, and that's the storage. So here we're going to get the new storage, and we're going to do the same thing for the decrement entry point. Expect also an int, and now we calculate the new value of the storage, which is going to be the int in the parameter minus the int in the storage. Once the pattern matching is done, we're going to indicate to Ligo that okay, now it's done, and we have the new value the new value of the storage by writing in. And now we can return the list of operation and the new storage. So if the list of operation is empty, you cannot just return it like that because Ligo is not going to know what kind of type it is. So when the list is empty, you actually have to type it explicitly. So operation list. And after that, we can return the storage. So here it's actually a tuple like this one. So when you return it like that at the end of the function, you don't really need to put parens around it. You can just write the left field, comma, and the right field. Here it's here you have to do it just to make sure that Ligo understand properly that that's the parameter of the function. Okay, so that should already work like that. Okay, so you see it compiles properly. Now, even if it's a fairly simple contract, in general you would like to extract the right side of each case of the pattern matching in a separate function to make it more readable. So that's what we're going to do here. So here, instead of having the addition happening here, we're going to put it in a function that we call add, and we're going to pass it the two values we want to add together, and we're going to put it here. So same thing to declare the add function. Let add, And so it's going to receive the value that's sent to the contract and the storage of the contract, and we have to type it too. So this value is an int and this value is a storage. So here you can see that actually if we just put int, it's still going to work, but in a more complex contract you still want to keep track of what types you pass to the different functions. So here it's clear that this function is going to do something with the storage, whereas this one is less clear, that something is going to happen with the storage. So that's why it's better to do it like that. And it's going to return the new storage equal, and now we just calculate the new storage, so n plus s. So in CameLigo you don't have a return keyword. The last expression that returns a value in a function is going to be the value that's written by the function. So even if we have some stuff happening here, some code, and that's the last value in the function, that's what is going to be returned by the function. And we're going to do the same for decrement. We're going to have a function called sub. We're going to pass it the value passed to the entry point and the current storage. Let's sub and s. So it's going to be the same types, and we're also going to return the new storage equal, and in this case n minus s. And it should still compile. Yes. So that's the code for the contract that you find when you click on Increment CameLigo. It's a very simple contract, but you can see that it introduces some key concepts of CameLigo. So the variant for the different entry points, the typing for the storage, how to separate some parts of the code in different functions to make it more readable, and how the main function works. So how you take the parameter and the storage and always return a list of operations and the new storage, and how you use pattern matching to tell Ligo which entry point is called with which value and how it's going to calculate the new storage. Now just for fun, we can add a new entry point to the contract to see how it works. We can do something very easy. So we have an entry point that increments the storage and an entry point that decrements it. What about just resetting the storage to 0? So it works like that. It's very easy. If you want to add a new entry point to an existing contract, you just find the type for the parameter, vertical bar, you give it a name, reset. So in this case, we're not expecting any value from outside the contract because we're going to reset it to 0. So there's no use. It's not necessary to pass a value to it. So the entry point is going to be called reset. Now we have to add this entry point to the pattern matching in the same fashion like the other one. So here you can see it's not going to take any value, and we're just going to return 0. And it should still work. Yes. So, and you can see here that's the part of the Michelson code that's going to reset the storage of the contract to 0. So I hope you liked this tutorial. It was quite short, but it was nice to introduce some concepts of CameLigo and how to write smart contracts with CameLigo for Tezos. Thank you very much, and see you soon.